So yeah, I'm a PM on Visual Studio Team Services. I own our Git service. We ship that, for external customers, but we also use it heavily inside the company. That's what I'm going to talk about. And I'm a much less skilled presenter than all the people who've gone before me. So if you look real carefully at, I think it's on slide 8, you'll see some color. But I'm going to try to talk about our process as a company of moving towards adopting one unified engineering system, what role Git plays as part of that system. And I'll talk about our own team, the Visual Studio Team Services team, how we have moved to Git and how we are using our own service, and some of the best practices within our team that we've learned and that we're sharing with the rest of the company. So, the old Microsoft way was every team kind of did their own thing. We had a really heterogeneous environment. Any team of any considerable size would have to decide what version control system they want to use. They'd have to build their own build system and test frameworks and build their own workflows around all of that. And there wasn't a lot of sharing across these team boundaries. And of course, that kind of environment creates all of the problems that you'd expect. It's really hard to share code, let alone, how do you even find it? How do you build it? Which server do you look at? It results in a lot of duplicated work across the company and building these components that ought to be shared, but nobody knows that they even exist. If you can find the right team to talk to and you need them to make a change in a piece of code that you need, it's often really hard to convince somebody to go do work on your behalf. It's a lot easier to just give them code that already does it, but you can't do that if you can't even find the code. It also just deters people from moving around because every time you move to a new team, you have to learn a whole new engineering system. So we figured there's got to be a better way. And we're trying to move towards a unified engineering system for the whole company. One that's centered around common tools, common workflows. We use Git heavily, we use NuGet heavily. We're building a common build and test infrastructure. But really the most important piece of all of that is to have a culture of sharing code across the company. We've been heavy contributors to open source, and we have begun to use open source quite heavily as well. But another thing that we're taking from that is the culture of being open, sharing code, and encouraging people to work on contributing back rather than having their own territory, so to speak. So the culture and the tooling really go hand in hand. You have to have the right tools to encourage the right culture, but you have to have the culture in order to use the tools. So we started off with this vision a couple years ago. Imagine a world where, and all of these things, imagine where anybody can find the source code, anybody can make changes. All of the intellectual property of the company is open to everyone in reusable components. These are all things that are not revolutionizing in the world we live in now, but they sure are quite different from where things were 20 years ago or even 10 or 5 years ago. Of course, the core of an engineering system is version control, and we think that Git is a good foundation for our unified engineering system. Git brings with it both the tooling characteristics and workflows that enable sharing, but also it brings with it the culture of sharing. So much of the open source world is in Git, and they just fit really well together. So across the company, we've already been adopting Git quite heavily. Many teams are already fully on Git. Visual Studio is in Git. Our team, Visual Studio Team Services, is fully in Git, Azure, and Skype. But there's also dozens of smaller teams, hundreds of personal, probably thousands of personal repos, and many, many more are in the process of migrating. Migration brings a lot of challenges with it. I think we had a talk earlier today about training people to understand Git. That is probably one of the biggest bottlenecks of people who have been working for years in centralized source control. You can't just throw them in a new repo and say go with a little bit of a tutorial. You actually have to retrain all the people. You have to build new workflows. You have to rebuild your tools and make sure everyone can be productive. So a lot of teams are in the process of migrating. For the teams that already are, we've begun to achieve a lot of the goals that we set out to achieve. The vast majority of our repos are visible to anyone in the company. The default of any repo that we create is that it's open to anyone in the company. So not only is it open, but it's in a shared place that anybody can go find. You can do a code search across a lot of these repos and find code that you're looking for. More importantly, anyone can submit a pull request inside any of these repos. And so we're already building this culture of, if you need something, you don't show up with a request, you show up with a pull request. You don't show up with a verbal request, you show up with a pull request. And the build and test infrastructures still are not fully standardized, but pull requests really go a long way to enforce the quality bars that any team wants to set. So it's safe for anyone to come in and play. You're not going to be able to break master if they've configured it that you can't push the master, you have to submit a pull request. So the tools are really helpful there. You'll see this is our, hey, some color. This is our Git usage across the company over the last several quarters. And just so we're specific on what these numbers mean, these are people that have done multiple interactions with our Git service over the course of a month. So they've done a fetch, they've done a push, they've created a pull request, they've reviewed a pull request. So they've done multiple meaningful interactions with our Git service over the course of the month in order to show up on this graph. And so usage is building quite rapidly. It's almost a hockey stick, maybe not quite. I imagine it's going that way. So we're learning a lot about scale in having so many different teams come on board. And we have a slightly different problem of scale than, for example, GitHub does. We are dealing with hundreds or thousands of repos within a corporation, and so we don't have the same problems of like unknown access patterns, but we do have the problem of there's a team that has about 2,500 repos because they've heavily componentized their code, and they have 2,500 repos that they build in order to build their product. And a particular developer needs to know, how do I find the right 3 or 4 or 5 repos out of those 2,500 to do my work? So discoverability is an issue. Creation of those repos and permission models around them and managing all the policies on them. There's a lot of management scaling issues there that we're working on solving. We also have a need to go quite large in some repos. There's teams that just have lots of people or lots of content. And so we have to be able to scale up to some quite large numbers. All problems that we're working on. But for now, I want to talk to you about our own Visual Studio Team Services team. We have what I consider a medium-sized team and repo. 300 or so, the number varies, but about 350 or so, I think, engineers working in the code and actively writing code. Our repo is about 2 gigabytes of sources at tip, and that's actual sources. There's no binaries checked in. About 100,000 files. And our cadence is that every 3 weeks we ship a new iteration of the service, we deploy our service, but also every quarter we ship a box product, Team Foundation server. And those are coming out of the same code base, and they have different release cadences with different requirements around each. And so we made an initial migration to Git a couple years ago, I think 2.5 or so years ago at this point. Where we took, Team Foundation server and Visual Studio Team Services are comprised of a bunch of different services that work together. And so our initial approach was, why don't we take each of those services, put them in our own repo, we can build them separately, each of them will be smaller. And we built some additional tooling. Like I said, every once a quarter, we want to bring all these together and make sure that they're all compatible with each other and that all their dependencies are the same version. So we have to be able to build them all together. So we built some tooling that stitched all these repos together. But really, it was a big pain for us. The code boundaries between those services are not as clean as we would like, because in the past, they were all in one centralized version control system, and there wasn't a need for necessarily super clean boundaries, and so we just hadn't done that work yet. And the versioning problems that we had when we wanted to ship the box product every 3 months caused a lot of pain. And so the result of all this was that developers had a lot of pain working across these repo boundaries. We had a lot of versioning debt we had very low engineering velocity. And so we took a look at what we had done and tried to find a better way. After this, we looked at submodules, and we actually built some rather robust tooling around submodules. The problem with submodules, they work just great for the problem that they solve, and you can build tooling to solve the problem that we had, but it compounds that education problem. Not only is Git just a DAG, or it's not, but when you use submodules, now you have a collection of loosely connected DAGs, and the mental overhead is just exponentially higher. And so, yeah, we built the tool and it worked, but we realized that we were going to set our developers up for even more pain. So, what we learned from all of that was you cannot make your repo granularity be smaller than your build granularity. And any attempt to do so just causes pain for your developers. So there's two paths forward to solving this. You have to componentize your code better. If you're coming from a monolithic code base and a larger team, you have to componentize your code, but that's not a quick and easy process. It's often a heavy investment. It takes a long time. And you also need to be able to support Git repos that are quite a lot larger in some cases than we had anticipated. So we're working on both of those problems. Since one of our products that we build is the Git service, we're in a unique position to make our own lives better by improving those tools. So what we did about a year and a half ago is we moved all of that code into one repo. And some smaller services, as they do the work of componentizing and making sure they're not taking any source dependencies and have clean boundaries, have been peeling off into their own smaller repos. But for the most part, we're in one large repo with all of that code. In parallel with that, we had to invest in our build. Like, you simply cannot put that many people and that much code into one repo without investing in how you validate the code. And I say build, really it's a proxy for validating the changes that a developer is submitting. You have to be able to build it, run your unit tests, do any sort of validation that you need to do to make sure that the changes are good. So we invested really heavily in our build process. We totally cleaned up all of our build scripts, and full builds went from 45 minutes down to less than 10 minutes. We, in the past, couldn't do reliable incremental builds, and now we can. And the net benefit of having a really fast, and really fast is relative, right? 10 minutes is still longer than I would like, but it's way faster than where we were. The benefit of that is you can have a much shallower branching structure. The model that we like to use in our team is anybody can submit changes to the master branch, but they have to pass the quality bar. And that simply doesn't scale if your quality bar takes an hour to run, but it can scale if you take less time. So it's really worthwhile to invest in those things. So now where we're at is we have one large repo. All of our development happens in topic branches that people spin off of the master branch. So master is just always trudging along. If a developer wants to make a change, they create a topic branch off of master. They work on that branch for as long as they need to, and then they submit a pull request to merge those changes into master. Once a sprint, we create a release branch off of master, because that's the build that we're going to deploy to the service. And if we need to make hot fixes, again, we create topic branches off of that release branch and pull request them back in. And actually, developers can't do it any other way. Our service won't, we configure it through permissions and branch policies so that you cannot push to master or to a release branch. You have to, the only way to get a change into one of those branches is to use a pull request. And our pull requests are then configured to run the build, require code reviews, run the unit tests. So we always have good quality in our master and release branches. The other thing that the pull requests do for us is they solve a scale problem. Anyone who has worked in a larger team and has tried to push to a branch like master or any sort of a shared branch knows that it can be really painful. You have to fetch the latest, you merge your topic branch into master, and then you try to push, and now you can't because somebody else beat you to it. So you have to fetch again, merge again, and push. You still can't because somebody else beat you to it. If you have changes going in every minute or two, you simply will never get your change in. And so our pull request infrastructure automates that for you. When you complete your pull request, we queue that request, that merge creation request into a queue. We process them one at a time. on the server. And as long as there are no actual conflicts, then your change will get in. So the server solves that race for you, and will only kick you out if there's an actual conflict that you have to go solve. So this is a very simplified view of our branching structure. The black line is master, and a topic branch can spin off a master and get merged back in. Sometimes you just need a longer-lived branch because you need 2 or 3 people working on something together. So we create feature branches off of master where a few people can collaborate. They can each create topic branches off of that, merge those results together, and finally do a pull request of that feature back into master. And at the top there, I got a quick little release branch spinning off. And we spin those off once every 3 weeks, like I said. This process works really well for us. And one thing we learned from this is you have to have, when you have that many people in a branch, you have to have a very consistent naming pattern for your branches. So what we do is we use this pattern of type / the name, right? So I have releases M98 was a branch that was spun off for the milestone number 98. If I want to make a small fix in a topic branch, I would name it user / my alias / whatever name I want. And this helps people organize the branches. It helps people discover what branches they need to find, when they're looking for them. And of course, there's a lot of questions around, like, what are best practices about? Do you have short-lived branches or long-lived branches? Do you merge or rebase? The answer to all these things is there's never one answer for the question, right? It really depends on the situation. So in our case, master and releases branches are always long-lived. The features and user branches are short-lived, and they have different policies that govern how they're handled. We configure the master and release branches so that you cannot force push to them. You can't delete them unless you have special permission, but most people don't. You cannot push to them at all unless you use a pull request. Whereas user branches, you can do whatever you want. You can create them however you like. You can delete them whenever you like. You can rebase them because then you can force push them, and that's okay. So our stance on merge versus rebase is no, you absolutely cannot rebase an important branch, right? And sure, you can go ahead and do whatever you want locally, but you can't push it to the server, so you can't inflict that on anyone else. But with a topic branch, we actually encourage people to rebase because that creates a cleaner history with fewer lanes in it. If you have 300 people merging into master and they never rebase, you end up with these really wide graphs. And so any tools that try to show you the graph actually become really hard to use because you can't find your way through all the noise. By encouraging people to rebase onto the tip of master before they merge in, and by the way, our pull requests always do a no fast forward merge, so you can't do a rebase and then a fast forward. You have to do a rebase and then a pull request, which always creates a merge commit. So you always end up with a clean graph that shows you the path of master, and if you look at the first parent history of master, you always see the exact history of that branch and all the merge commits that went into it. But you can look at the other side of the merge commit, the second parent, to see what the topic branch was, and it creates a really clean history. Of course, users don't remember all these rules. The way to make people successful is to enforce them on the server. And so we set up all the permissions and the branch policies to make this happen. So you actually can't mess it up. If you accidentally rebase an important branch and you try to push, you're going to have some work to do to clean up your own state, but you didn't hurt anyone else on the team. So that sort of tooling is really important to help users be successful. The end result for us is that we have improved velocity and improved code quality. And because we're a largest team on the server, we feel the pain of these sorts of things, and so we're very motivated to fix them, which makes life better for all of our customers as well. And one huge benefit of this for us has been, like, we're actually achieving what we wanted. We get significant contributions from others in the company. Nowadays, when somebody comes to me and says, hey, I want this great new feature in your service, I say, great, come to me with a design, and then I'll tell you where you can write that code. And you can start contributing that code in. And a lot of teams have done that. We've been getting very meaningful contributions from around the company. That's been really cool. So currently our repo is at about 16,000 branches. It's still about 2 gigs in the working directory, about 5 gigs in the history. So about, I consider that medium size, like I said, but we're eyeing much bigger repos and working on a lot of things in that space. Overall, we're on a journey. We're moving towards this one engineering system. We've made a lot of progress. There's still plenty to do before the whole company is on board. But Git is the foundation of it, and we're working hard to make sure that it scales to all of our teams, and make sure everyone is successful in using Git. So, thank you. I don't know how I'm doing on time. If we have any time for questions. Yep. Yes.
Can you talk a little about the work you're doing to handle large repos, and do you plan on open sourcing any of them?
What work are we doing on large repos, and are we open sourcing? Let me just talk about the scale problem. I'm going to be a little bit vague on it, but the three scale problems that we have to solve is the number of branches that exist in a repo, because that affects a lot of operations like fetching or just local operations that a user does. The second factor is the number of people trying to merge into a branch, which I talked about before, and then the third is the size of the repo. We are planning on all the changes, the improvements that we make in those areas. We are certainly planning to open source whatever those changes are that affect Git itself. Some of the changes are just in our service. That our service is not open source, so those don't get released publicly. But any changes that we make, we do everything we can to release them out publicly. Yep. Yes.
So anecdotally, I would agree that better code velocity and better code quality in terms of I think Git workflow in comparison to say Source Depot or something like that. But how have you measured that company-wide in terms of that change?
Right. So how are we measuring improved code velocity rather than just talking about it anecdotally?
And quality.
And velocity and quality. Well, actually, we're working on. This is another one of those areas where different teams have done things differently, and we're working on unifying it. But we actually have a fair bit of telemetry that we gather from our Git users, and we can measure things like how often they're successful in interacting with source control. We're working on being able to measure how many times they actually interact locally with Git before they even try to interact with the service. And in addition, we have a lot of telemetry on the server about how often, how long pull requests stay open, how often they fail to build before they're merged in, how many iterations it takes to pass, and we gather data on how often the build breaks once it's in master, because that's the one you really care about. So yeah, we don't have a complete answer yet, but we're certainly working on getting really good visibility into that sort of repo health. Yep. Any others? Yep. Yep. Why do we have so many branches? It's because we tell people branches are your friend, create as many as you like, and we have 300 or so people creating lots of topic branches for all the work items they have. They're not necessarily the best at cleaning them up afterwards, right? So one recent-ish change that we made a few months ago was that when you complete a pull request, we now automatically delete your topic branch. That wasn't always there, so some of that is cruft. But I mean, if you have 300 people on average keeping 10 or 15 branches alive, which is reasonable, the numbers add up. Yep. Yes?
What are you using for Git server?
Visual Studio Team Services. I mean, if you're not familiar with the product, we host version control, work items, build, release management, all that stuff.
You dog food your own.
That's right. Yep. All right, I think that's probably all the time we have. Thank you, everyone.